Hey guys, welcome back to this tutorial on Raspberry Pi and Arduino integration. In the previous tutorial, we saw how we were able to write data from the Arduino and send it to the Raspberry Pi via the serial communication, and also do the same from the Raspberry Pi to the Arduino. And we saw that we were not able to do it concurrently at the same time. So in this tutorial, we're going to see how we're going to implement a bidirectional communication. So basically, the Raspberry Pi can send data and the Arduino can see the data. And when the Arduino serial print the data, basically it will be going through to the serial, and the Raspberry Pi will also going to catch it via the Pi serial link. And then when we are done with that, as promised, I'm going to then implement the LCD display. As you can see here, this is a LCD breakout board for this Arduino. It will be like an add-on board, and we're going to see the message being sent from the Raspberry Pi into the Arduino so that we can catch it on to our LCD here. So stay tuned to see how we're going to implement that. Okay, so now before we begin, I would like just to change something quickly into this Python code. I realized that we were repeating the code into our receive data and send data program. So I'm just going to basically just cut this here, right? And I'm going to paste it here to establish the connection. So basically we're going to establish the serial connection from the start of our Python script here, so that when we're going into the Python function, then the serial communication have already been established, so we don't have to repeat the code. Okay, so if I run this program again, we should still be able to connect, okay, and then transmit data. Okay, so we basically just stuck into one of the program, which is the send data. So that is this one. We're not exiting in there because we're staying inside the while loop. Okay, and now we are not able to see the data. So if I click on the serial here, there is no data coming through, although we are basically sending data. So this is where I'm going to use the LCD so that we can see how we can capture that data. But before we do that, there is a way in which we can get data from the Arduino. Okay, so but before we do that, there is a way in which, as we are sending this transmission in progress, we are sending data from the Raspberry Pi into the Arduino, as you can see with the flashing transmission LED there. Now the data are going to be coming, then the Arduino is going to read it and serial print the data that the Arduino is receiving, as we are now reading here, right? So we are sending the data into my data, but now we're not doing anything. So if I do serial print of this data, okay, that means I will be able to send the data via serial, but we need to just write a simple trick into this code so that we can distinguish the data that we are sending, because we're not going to, for now, entering data live as we are sending. All right. Okay. So I'm going to stop this code here, and I'm going to move into the Arduino here, and I'm going to add a serial print line into this receive data so that we can serial print the data that we are receiving. And also guys, please, if you like this tutorial, don't forget to subscribe to SimTech channel and give this tutorial a thumbs up. That will be highly appreciated, and I thank you so very much. Okay, now I have the serial monitor open from the Arduino, which means if I run the Python script, I won't be able to access a serial port because it is busy, occupied by the serial monitor itself. So we got the serial exception here. Okay, now in the coming tutorial, we'll be able to write a small script to be able to handle this exception, and for a certain amount of time until it time out, and the program should exit peacefully without crashing. Okay, but that's a subject for another tutorial. So I will have to close this window in order for the script to access a serial port. So we saw that in the previous tutorial. Right. Now, even though I have the serial monitor open, I can be able to send data via this window here. So if I type test and send, I'm not seeing what I'm sending. It should appear here. Why? Because I do not have the serial print line of code here. So I have to include that here. So I'm then going to include the serial dot print line. Okay, so what am I going to print on the line? I'm going to print my data, obviously what I'm receiving from the Raspberry Pi. Okay, now what I'm going to now do is to just compile and upload this code into my Arduino. Okay, so the code is already done uploading. Now if I open my serial monitor, obviously nothing is coming, but now I can test it here. So if I say test and enter, now you can see the date stamp where I'm sending the data. So let me just remove the date stamp. Okay, I'm sending test. This is what I'm sending, and I'm catching it, and I'm also reading and printing it at the same time, because we are going to test data coming from the Raspberry Pi here. So we're just writing data from Raspberry Pi, but in order for us to see that data are being sent after every second, as you can see, there is a time of 1 second, but it is the same data that are going to be sent. So we need to add a tag on it, so that every time we receive that data, we tag it so that it says that it is a new data from the Raspberry Pi. It's not the same data. So in order to add a tag, we then just going to come and initialize a variable int tag, and then we're going to initialize it to be equal to 0. And then we're going to come here, and what we're going to then do is we're going to take my data, okay, or let's change it to something that is more appealing. So let's say it's message from Pi. So we're gonna say MSG Pi, so we know that it's a message from Pi. So basically I just need to change this as well, MSG Pi. So it is a message coming from the Pi. So what I'm going to then do is I'm going to then say, well, the MSG from Pi is then going to be equal to the MSG from Pi, right? So that's the message from Pi plus, okay, my tag here. So the variable tag, right? So I'm going to then put a tag there, right? But this line of code will not compile, right? Because you are trying to concatenate a string here, which is MSG Pi with an integer, right? Int tag is an integer. So what you have then to do is you must then put it into a string. So you have to cast it into a string like that. So this is now going to be a string, and then we just want a space. So basically to include a space, we're just going to add a double quotation there, right, with a space, and then we're going to add another plus. So this, our compiler is going to be happy. We're just inserting a space, and then we're inserting our tag. So that basically will give us a message plus the tag, and then we then going to send the tag right into the serial port. Right, now if I then compile this into the Arduino here, what problem are we getting? We're getting initializer before int. What's going on? Oh, okay, semicolon is missing there. Right, now let's go. Okay, so everything is working. Now I'm going to open the serial window again. So now if I write test, okay, we can see that test got a tag of 0, right? Now if I write test again, it still have a tag of 0, so there is no clear indication that this is a new message. Now to fix that, I need then to increment my tag. So I just need to then come here, and then I'm going to say tag plus plus. So basically I'm incrementing the tag. So then I need to load this code again into the Arduino. Okay, so bear with me guys, and then we can then say again test 0, test 1, test 2. So every message I'm going to receive on this point forward is going to have that tag, and the tag will be incrementing. And believe you me, now if I do this, right, so I send, so now when I run the Python script, I'm sending the same data. I'm now sending is actually coming through, right? It is coming through, but I'm not seeing it because I'm not handling it. But now if I then open my serial monitor, we will be able to see the data that the Raspberry Pi is sending into the Arduino, and the Arduino is tagging all of them. As you can see, we're coming from all the way to 0. Now we are up to 23. So data are now being sent every second by the Raspberry Pi, and we are tagging them. Now we are not seeing this response because, mind you, this, what we see here, is a serial print that the Pi here, the Raspberry Pi, via the Python script, should now be able to catch all this data and also have it here, right? Okay. Now, what we're going to do here is then to be able to catch the data from the Arduino into the Raspberry Pi by calling the receive data. So what I'm going to do now here is I'm just going to close and stop this program. So I'm going to then modify the receive data program so that I can call it right under the S data right we are doing there. So I'm going to remove all this old line of code. So in order to receive the data from the Arduino, I will then have to then copy the receive function here because we already did test that in the previous tutorial. So I'm going to paste it here just under the write, right? Because we are now writing into the serial port sent to the Arduino, and we also going to receive just after writing. But we then need to pause for a fraction of a second after writing. That's what we're doing here. And then we're going to check if they are indeed data in the waiting list so that we can do the reading. But before we do that, we need to change this condition in the while loop. Otherwise, we're going to stuck in this while loop and we're no longer going to exit and do the write. So we'll only be reading. But mind you, we are reading exactly based on the response that we are sending from the Arduino with our write. So if the Arduino here does not read anything, it's not going to be able to write anything on the serial port. And if we cannot write, we're not going to also receive anything. So we need to get out of this while loop. So to do that, I'm going to copy this condition we did for the if statement here and change it onto the while true here, right? And then I'm gonna then remove the if statement. Then I need to move this line out of the while loop, right? Because after doing the checking if they are data in the waiting list, I need to exit that while loop after pausing for this fraction of a millisecond there, and then I must do my reading, and then I can print it into my console here. Okay, then the function is being called. So let's give this a try and see what going to be the possible outcome. So we can basically just comment out this one because we basically just on the send data there. Now let's run and see what is the story here. Arduino connected. Okay, you can see we are transmission in progress. We are sending. The Arduino is tagging the data that we are sending. So now it's clear that we've achieved a bidirectional communication between the Raspberry Pi and the Arduino, because we can see that we are sending data from the Raspberry Pi into the Arduino. The Arduino is receiving data, is adding a tag on it, okay, and then sending it back. So the data are now being captured on the Raspberry Pi with a tag. So it's no longer the same data. Now I'm just going to add a quick modification here before we can then implement the LCD screen into this little demonstration. So what I'm going to do here is I'm going to copy this print here. I'm going to remove this print because we already know that we are sending that data. So I'm going to remove that print. I will put it here. I'm going to then say Pi. So basically this will be what the Pi is sending. And then I'm then going to add the data that I'm sending. So basically this is what the Raspberry Pi is sending into the Arduino. And then I'm going to come into the receive data function. And here I'm going to also include a small tag here, basically just to indicate that the data are indeed coming from the Arduino. So just to make things short, I'm just going to say Uno. So which means the data are coming from the Arduino Uno and the Pi is sending. So basically what we're going to see will be Pi data from Raspberry Pi. And on the receiving side, we're going to have Uno data from Raspberry Pi with the tag, because that is now coming from the Arduino. Okay, and I also just want to make this line here very short, so I'm just going to say Raspberry Pi, and basically we're also going to receive Raspberry Pi with a tag. Okay, so now let's run this again. There is nothing we have to change on the Arduino side there. So basically we can see Pi is a Raspberry Pi, Uno is a Raspberry Pi 1. So we sending, we receiving, we sending, we receiving, we sending, we receiving. But as we can see that there is a communication going on here. We are sending data and we are also reading the response with a tag. Now we only seeing this through the Python console. Now we are unable to basically see it here with a serial monitor, because when we open a serial monitor, there's going to be some disruption into the communication. So there is an attempt to read and write on the same port, and then there is a clash. So basically, if we want to now see the data on the Arduino side, the only implementation we have here is a hardware implementation. So this is where including an LCD display here will become very handy. I've got a very small LCD display here. I'm going to now attach it onto my Arduino here. And we're now going to modify this code. Basically, just add a few lines of code so that we can connect the LCD and send now the data. Basically, we're going to write the data that's coming from the Raspberry Pi and also the data that we are sending. So that way it will be basically the same information we're getting here. Send, receive with the tag. We're also going to be able to display it on the LCD. We start crashing the serial monitor here like that. Okay, so let me then implement that quickly. So stay tuned. Okay, so I'm going to remove the Arduino from the Raspberry Pi, and I need to put this add-on like that. Okay, so now the add-on is connected. Now if I put it on, well, there is nothing we can display on the screen. There's nothing because there is no LCD implementation here. So we're basically going to use the LCD library from the Arduino to implement what we want to do here. So this schematic is basically for this LCD display add-on board for the Arduino. Now, as you can see right here, this is the header pin where my LCD is connected. So the connections, I'm using the Arduino IOs from 2 to 7. Okay, so IO 2 and 3 are being used. IO 2 is for RS and IO 3 is for the enable. So this is the 4 data lines. And then the rest of the IO, that is from 4, 5, 6, and 7, I'm using them for the data line. Okay, RW is then basically grounded, and the rest of the data lines are not connected to anything. And I've got a port here, which is this potentiometer, that is basically just to control the contrast of the LCD display. So this is a 8x2. So to implement the LCD library code into my Arduino, I need to find the example for the liquid crystal. So these are a few examples. Let me just take for display. Okay, so I will just expand these and see what kind of implementation they have here. Okay, this is the explanation what they're using it. So I just need to copy the include. Right, I just need to copy the include header file because that's where most of the functions are. And I also need this line of code, so I'm basically just going to copy that as well and paste it right there. And I just need to change it here. I'm using a 8x2, so I'm just going to change here. RS is on pin 2, enable is on pin 3, and then the rest are pin 4, 5, 6, and then pin 7, like that. Okay, so now the next thing is just to basically initialize the LCD, just like we were initializing for the serial communication. So I'm just going to say LCD.begin. So into the begin function here, we need to pass a parameter of our LCD. You can see that I'm just going to say 8, 2. Like that, and a semicolon. So now the LCD is ready. So the only thing that I need to do now is to basically print the data into my LCD. Okay, so now we're almost done with the LCD implementation. The only thing we need to do now is to basically print the LCD data into our display. But because I want to print a message from the Raspberry Pi into the first row here, and the Arduino response into the second row, so I need to indicate where my cursor is going to be. So I'm going to then call lcd.setCursor function. Okay, and in this function I need to pass the parameter that will be 0 and 0 because I want to be on that first row. Then I can then say lcd.print. Okay, now I can pass the message where I want to print. I want to print what I'm receiving from the Raspberry Pi, so I'll just paste it in there like that. Now I can then just copy this line of code and do the same implementation basically here, right? And I'm going to now change the parameter for the LCD set cursor function into 1 now here, so that we can move from the first row into the second row. Okay, so that is then the 1 there. And now the message is going to remain the same message, but this time it's going to have a tag on it. That's the reason why I'm placing it right here, because if I place it before I'm assigning the tag, then it's basically going to be the same message. Now let's compile first before I load this code. Hopefully it's going to work. Now let's upload the code. Uploading the sketch. We can just close this. We're done with that. Okay, done uploading. So what are we getting? Okay, we're still not getting anything. The reason why we're not getting anything because we are not sending yet. So we first need to send data into the Arduino. So I need to run the Python script so that I can actually start sending data. Okay, now you can see I'm just getting Raspberry. So it's working, but because I cannot fit in everything, unfortunately the LCD is small. But now if I need to see what I'm printing here, basically I need to then reduce what I'm sending. So to reduce that, I basically just need to change this. So I'm going to change this line that I'm sending, and I will basically just write a short message. So Symtech, right? So Symtech. So let's just basically write Symtech because we know that Symtech is going to be able to fit in there. That's what we're going to be sending. But what we're going to now receiving from the Arduino will have Symtech and a tag. So let's run this and see what we're going to get onto the LCD display. Now you can see we're getting Symtech and we're getting a tag. Symtech and we're getting a tag. Symtech and we're getting a tag. So it is working. So we are sending data and we are replying with a tag. So this is a bidirectional communication that's now been achieved. And as you can see here, this communication is being controlled and initiated by the Raspberry Pi. Because if I stop the Python script here, so the communication have been interrupted, and you can see that the Arduino is not replying anymore. The tag have stopped, and you can see it stop at 35 there on the Arduino, and it's also stop at 35 there because there is no more communication. This is the last transaction that they have, the last conversation. So to initiate the conversation, you have to restart the Python script again on the Raspberry Pi side, and then you have the conversation going. So this is how this bidirectional communications can be implemented and controlled from the Raspberry Pi. Now, if you want to make this like a proper communication, you can make this code fancy on the Arduino side. Basically, you can check the message, so what you are sending, and then you check what the Arduino is replying. If what the Arduino is replying is equal to this or that, then you reply this way. Now you can create a conversation, but these are just hints I'm giving. But this is basically how you can create a bidirectional communication between the Pi and the Arduino. Okay guys, so that will be it for this tutorial. Thanks for watching. If you find anything useful in this tutorial, please give it a thumbs up and subscribe to Symtech channel. And if you have any question, you can drop a comment in the comment section and I will attend to it as soon as possible. Thanks for watching. Until next time, cheers.